1.7 and then hopefully 1.8. 1.7 is the last rule we have to look at. I shouldn't say the last rule because there is something else in the next chapters that we will talk about. But for now, we know how to differentiate the sum, the difference, the product, and the ratio. So something called the chain rule really talks about differentiating a function of a function. So we have a function inside another function. And I'll give you examples in a moment. This notation is f comp g, the composite of f and g. It can be g and f, it can be f and f, but for this notation, it means this is the outer function, and this g of x is the inner function, of course. So how do I know that this is the case? Well, just to remember, g is the closest to f. G will be applied first, and then f. So this is something like this, with 3 bubbles. X is here. First, we apply g to get g of x, and then we apply the outer function to g of x. Oops. And we get f of g of x. Okay? Examples, almost everything. Here's an example. The square root of x squared plus 1. Can anyone give us what is the inner and what is the outer function for this? Is anyone with me? Anyone would like to try?
Is the inner function, I'm just going to take a guess, is it x squared plus 1?
Yeah, this is not a guess. You have to evaluate this first, no matter what. Where are my props? I lost my props. So this is what I have to evaluate first. If I don't get this done first, I cannot apply the square root. I don't know what to apply the square root to. So this is not a guess, right? So this is the square root of x. Very good. Okay, here's another example. 1 over x plus 1. Can anyone give us the inner and the outer?
The x plus 1.
Of course.
The inner.
Of course.
And then 1 over x.
Of course. Exactly.
Or whatever.
Exactly.
The next listed is like 1 over x.
That's the function that we apply to x plus 1. We apply 1 over x, of course. Excellent. Great job. Okay, so now let's talk about how to differentiate something like this. So that's what it's the chain rule all about. Differentiating not the sum, a difference, a product, or a quotient. I should also put here power. We learned how to differentiate a sum of functions, a difference, product, quotient, and also power rule, right? So now we are learning how to differentiate, it's called the chain rule, how to differentiate outer of an inner. I can have more than just outer and inner. Here's an example. So let's say I have the square root of x squared plus 1 to the third. What is the innermost here? I have 3 functions here, at least. What is the
x squared plus 1?
Yes, that's the innermost. Awesome. Thank you, Rachel. What is the next one?
Taking the cube root of that.
Careful. What is the next one?
Cube root, cubing it.
Exactly.
I meant using that exponent 3, and I just said it wrong.
Very good. And now the last one.
Squaring it.
That's it. Not squaring it, but a square of x. The square root of x. So this is done first. When I'm done, I have to cube. When I'm done, I have to take the square root. So as you see, we can have more than 2, an inner and an outer. We can have etc., and as many as you want. Okay, finally, how do we differentiate this? So when we have a function of a function, to differentiate, we will differentiate the outer function first of the inner. I have to copy. F is applied to G, multiplied by the inner function prime. And that's it. So here's an example. First, let's talk about, let's say, a function raised to a power. This is n. You can put m. You can put anything you want, as long as you understand what I'm doing. So when we have a function to a power, we follow the same rule we used last time, in which, if you remember, I said x to the nth prime is n, x to n minus 1. And then I said times x prime, and you told me there is no need, because this is 1. Correct. But this is a function. It's not x. Now I have no choice, and this is what follows. I have to multiply by the inner function prime, which is f. Of course, prime. So the outer function is power n. The inner function is f. According to the power rule, I bring the power in front, I subtract 1 from the power, and now I have to multiply by the inner function, which in this case is this, prime. So let's work on some examples, and you'll see how this works. Page 171. So let's start with 7. Like y equals the square root of 1 minus x. I just recycled, of course I can take them out of my bin. I just recycled the square root. Can anyone refresh our memory on the square root prime?
Is it 1 over 2 square root x?
Very good. But now, since I'm going to have a function here, what do you think the change will be?
The function.
The function goes under the square root symbol.
It's the same thing. If I, instead of x, I have f, the square root of the function prime is 1 over 2 the square root of the function, but this time I need to multiply by f prime. So it's the same formula. Let me write it again nicely and neatly. So this is my page 3. Okay, so let's write it again. So the simple rule for plain x is 1 over 2 the square root of x. And if you remember, I wanted to already get you used to it, times x prime. There is no need, because this is 1. But in any other case in which I have the square root of a function prime, I follow the exact same rule, 1 over 2 the square root of the function. If I have x, now I have f. If I had x before, now I have f. But this time, f prime is not 1. So I have to put it in. It's nice when it's 1, but in this case, it's not. So coming back to our example, let's do this. So this is, I'm going to copy it here one more time. Can anyone tell us what to write, at least initially? It's okay if you're wrong. Really.
Would the first step be to do 1 over 2 square roots of 1 minus x?
Excellent. Times. So now forget about the square root and just differentiate this. And put it here.
Minus 1.
That's it. The constant prime is 0. X prime is 1, but I have a negative 1, so I have to write negative 1. Awesome. So the final answer is negative 1 over 2 the square root of 1 minus x. And we used the chain rule. Okay, let's take a look at a ratio. A simple one first, something like 13. Because I'll assign 14 for you, so I want you to have enough examples to work on all your homework problems. 4x plus 5 squared. So there is a catch here. So the catch is, will I use the quotient rule? No, not when the top is a constant. I don't recommend it. Can you? Yes, of course, you're free to do it. But I will differentiate this. Instead of this. It's a matter of preference. You can use the quotient rule. You'll get the same answer. If you use the quotient rule and I use the power rule, that's not going to make any difference. Okay, assuming you go along with my suggestion and we differentiate when we get y prime. Remember, I bring the power in front. I subtract 1 from the power. And then I have to multiply by the inner function prime. What is the derivative of this function?
Four.
Excellent. So this is negative 8 over 4x plus 5 to the third. You could say, well, you still end up changing into a fraction. Why don't you use the quotient rule? We can, but we have to be very careful because when we differentiate 1, we get 0. So you still get the same thing with minus in front. And you have to simplify later. So it's up to you. Any questions on 13, please? Any questions on 13? Okay, let's practice some more. Okay, let's look at 21. 21 is a combination of chain rule plus product rule. How come? Yes, because this is function 1 and this is function 2. So now I have to use the product rule and then eventually the quotient, the chain rule. So let's do that. F prime. Do I need to refresh your memory on the product rule?
Yes.
Very good. Sipping a little bit of water. So 1 times 2 prime is 1 prime times 2 plus 1 times 2 prime. So when I differentiate the first function, I get 2x.
I'm sorry, Professor.
Yes, I'm ready.
I don't know why. I've been trying to scan my work, but every time I save it to PDF, it keeps coming up as an error that can't be read.
Can you please text it to me to 240-675-0445?
Hold on, let me write that down real quick.
Yeah, it's right here. I'm not going to erase it.
Can
It's
I
on.
just send it as a JPEG this once? I'm sorry.
That's fine. Okay, so it's on the syllabus. Anyway, so
All right, thank you very much.
no worries. So we differentiate the first function and we get 2x. Then we multiply by the second function as is. Sorry, I have to write plus here and continue here. Sorry about that. I copy the first function and I multiply it by the second function prime. Well, I need to remember that this is the chain rule. And I have to write it as 1 over 2, the square root of 4x minus 1 times the inner function prime, which you told me on the previous problem. Same thing. So that is good, but not good enough. I'm going to try and simplify, first of all, by 2. And this is how it looks now. 2x the square root of 4x minus 1 plus x squared over the square root of 4x minus 1. The least common denominator, so we have to continue here. There is only one denominator, this is over 1. So then there is no discussion. The least common denominator is the square root of 4x minus 1. And because this has 1, I need to multiply the numerator by the square root of 4x minus 1. When I multiply these two, the square root goes away. So I have 2x quantity, 4x minus 1, and then plus, careful, careful, I forgot to write it, 2x squared. So plus 2x squared. What I like to do here is factor out 2x. And then 4x minus 1 plus x over the square root of 4x minus 1. And I just had a study group, and one student said, well, here's why calculus is so much easier. You're done. All these are just algebra. All these steps are algebra. Okay, so 2x, and this is 5x minus 1 over the square root of 4x minus 1. Remember, we want the numerator to be factored.
Sorry, I think I just lost everything you said.
Yeah.
Same.
Right.
Yeah, there's a good like 10, 15 seconds
Same here.
of silence.
Oh,
Froze.
was it at my end?
Yeah.
Okay,
Yeah.
let me repeat what I just said. Did you all hear this part?
That's where my connection failed.
Okay, so till this point it's okay, correct?
Yes.
Okay, so then I copied because I really wanted to see it in one row. Because I wrote, silly of me, I wrote my phone number here. I should have probably put it up there. So I wanted to see it in one row. So I just wrote it again, and I had 2x squared over the square root of 4x minus 1. Now I'm adding two fractions. I need to find the least common denominator, but there is only one denominator, so obviously that's the denominator, the least common denominator. Because the denominator here is 1, I have to multiply the numerator by 4x minus 1. Because I multiplied the denominator by 4x, the square root of 4x minus 1, I have to multiply the numerator. So when I multiply these two, I get 4x minus 1. I also have a 2x in front. Now, I prefer, that's my preference, factor first. I factor out 2x. So I have a 4x minus 1 plus from 2x squared. If I factor out 2x, I'm left with x. Then I combine these two. And I was just saying that I just finished a study group half an hour ago or 25 minutes ago, and a student said to me, and I understand he's right. He said, here it is. Calculus is still here. And then you had 3 more rows to explain for algebra. That's true. I understand.